Dear physics aspirants, right now motion in a plane chapter 4 I have, and in previous video I have discussed introduction, and in this video I will discuss scalars and vectors. These two process is based on motion in a plane. When you study motion in a plane, then introduction will be needed and scalars and vectors and understanding will be needed. Physics, we can classify quantities as scalars or vectors. Basically the difference is that direction is very important in a motion in a plane. When motion will be in a plane, then direction will be needed. Direction is associated with the vector. Direction is associated with vector and vectors, but not with scalar. So scalars haven't direction, vectors have direction. And here a scalar quantity is a quantity with magnitude only based on scalars. It is specified completely by a single number, i.e. scalars, along with the proper unit. Unit is very important for the significance of the ending process, and examples are the distance between 2 points, mass of an object, the temperature of a body, and the time at which a certain event happened. So the rules for combining scalars are the rules of ordinary algebra, and scalars can be added, subtracted, multiplied, and divided. 1 2 3 4 actions have been worked. Now I will go to the next page. Here you will see just the ordinary numbers. For example, if the length and breadth of a rectangle are 1.0 meter and 0.5 meter respectively, then its perimeter is the sum of the lengths of the four sides. 1.0 meter plus 0.5 meter plus 1.0 meter plus 0.5 meters is equal to 3 meter. The length of each side is a scalar and the perimeter is also a scalar. Take another example. The maximum and minimum temperature on a particular day are 35.6 degrees Celsius and 24.2 degrees Celsius respectively. Then the difference between the two temperatures is 11.4 degrees Celsius. Similarly, if a uniform solid cube of aluminum of size 10 cm has a mass of 2.7 kg, then its volume is 10 to the power 3 meter cube. A scalar and its density is 2.7.10 to the power 3 kilogram per meter cube. It's a scalar. A vector quantities. Now we will discuss about the vector having direction. A vector quantity is a quantity that has both magnitude and direction. So previously in scalar we have studied scalar has magnitude only, and in vector magnitude and direction both have with the vector, and obeys the triangle law of addition. What obeys the triangle law of additions, adding, or equivalently the parallelogram law of addition. So a vector is specified by giving its magnitude by a number in its directions. Some physical quantities that are represented by vectors are displacement, velocity, acceleration, and force. Displacement, because displacement, when you go to one place to another place, you have the direction. Velocity, when something is going in a direction, velocity will be based on the direction, acceleration also based on direction, and force. When we apply the force, the something displaced in a direction. So with along with direction, we are discussing the vectors and magnitude and directions, both the two. To represent a vector, we use a boldface type. In this book, this is a velocity vector can be represented by symbol V, bold V. Since boldface is difficult to produce, when written by hand, a vector is often represented by an arrow placed over a letter, say this. Boldface is difficult to produce every time, so the V is an represents the velocity vector, both the two. The magnitude of a vector is often called its absolute value, indicated by V. Magnitude of vector is often called its absolute value, indicated by V and also V. Thus the vector is represented by boldface is A, P, Q, R. XY with respective magnitudes denoted by light face, with respective magnitudes denoted by light face A, P, Q, R and XY. So students, we have studied scalars and vectors. In next video I will discuss position and displacement of vectors. 4.2.1 will be our next course of action. We will meet in next video with the content. Till then, thank you.